So there's a few more repairs I want to do to this bucket. It has a fair amount of slop in it, but almost all of it is coming from this pin. I had originally intended to include this in the bucket repair video where I welded up the bucket, but this turned out to be a much more involved and time-consuming repair. It took longer than welding the bucket, actually. So I want to fix that. This thumb, for whatever reason, is cracked here and here, which I find interesting because the thumb, you know, the pressure when it's closing, that would be in compression. It would be pushing that together. I don't know why that would crack unless someone was trying to pull with the thumb. The other thing is, this pin that the thumb cylinder works off of has a bushing right here because that's a smaller pin. But the bushing was welded on this side, but you can see it's fallen off. So I'm going to fix that. I also want to fix this side cutter. It's loose. Now Yanmar has a quick attach function on most of their excavators. It's kind of cool, as long as it continues to work, which it does work just fine now. See that right there? That's a hydraulic cylinder that I can control from the cab. And what that does is it pushes this and this in opposite directions. And you'll see it better, but that is what is holding the bucket on. It's grabbing this pin and this pin by pushing out with that cylinder. So if I go in the cab and then tell that cylinder to retract, it's going to let go of the bucket. I could change buckets without getting out of the cab is really what it boils down to. But I'm going to go ahead and take the bucket off since I'm going to be working on this pin. There you can see all there is to that bucket is just those two pins and these two hooks. And there's the cylinder. Inside the cab I just have this control box here. You just hit power on and you turn it this way to dismount and the other way to mount. Pretty simple. Well, this is not what I wanted to see. There's all my slop. It's not the pin. It would have been nice if I could just replace the pin, but nope. Gotta fix that. And that's not even round, so it's not like I can just press a bushing in there. This side's not quite as bad, but it still needs to be fixed, both sides. Hit me right in the mouth. How's that thing supposed to come out of there? It's got to be a pin. It just doesn't want to move. This is one side of the hydraulic cylinder that I'm failing at taking apart. So I decide maybe I'll try the other side. Man, this thing does not want to come apart.
It looks like there's two short pins, one on either side, that are driven in and have to be pulled out.
I wanted to try and see if I could take a bolt and thread it down in there and push this out of there, maybe. That bolt's getting tight, darn it. That's probably not the best idea. I don't want to mess up the threads in it. I think it's moving a little bit. Yeah, it sure is. Not the prettiest way to get that out of there. Yeah, that's going to do it. Get the other side, then I can take that cylinder off. That's going to make this a lot more manageable. Worth the effort. This is a Japanese machine. Pretty much metric top to bottom. At least that's what I thought. That is a 1/8 NPT pipe thread. 28 threads per inch. What's that doing in this thing? One of these days I'm going to buy a slide hammer. I say that whenever I need one and then I don't. Alright, let's get smart instead of stupid. Man! I think I missed the money shot. I just started hitting hard and out it came. Thank goodness. That was getting old. So set it back up there just to get a look. Look at how much slop there is in that. I can stick my finger in it. The other side, not quite as bad, but pretty bad. Best I can tell, the best that I can do is use the outside of this collar here to use that as my center. And I'm just gonna have to get close. I can't, there's no machine surface or way for me to know for sure that I have the hole right down the middle. But that should be fine, because there's a lot of flexibility in the way these go together. The other thing I noticed, now that I've got it cleaned up, there's set screws. That might have made it a little easier had I known those were there. Fits like a hot dog down a hallway. This is going to be a challenge for this little mill, but it has some tricks up its sleeve. I am going to have to take the vise off, so let's start with that. Yeah, so this is probably a job for a line borer, which I don't have. That's basically a boring machine that you weld on, and you know, it's like mobile. You can do it anywhere. This thing's so irregular, I don't have any good way to clamp it down. I mean, I could, this is probably a good machine face, but it's all the way out here when I need to be boring over there. These are not at the same height. So if I put this on the table, then I'm going to be shimming that. It could work, I guess. The other side, this is definitely not a true surface. This sticks out. That's probably not true either. The rest of it's, looks like this is cast steel. Yeah, I don't have a whole lot to go on for mounting this thing on the table. My mill has a trick though. Looks like a vertical mill. It is a vertical mill for the most part. But see this? I can rotate that entire cutting head sideways and I can come at it this way. So I think this is going to be the better way for me to hold it. So let me work on that for a while. Once I get it held down, I'll bring you back. Basically, this mill can also function as a horizontal mill. It's not something I've ever done with it before. I'm hoping going horizontal is going to make this project easier for me. But hope all you want. I've got to do it the hard way. Well, that looks like a change of plans. Yeah, it was somewhat disappointing.
When I turn sideways, the head's all the way out here when that's sideways. And even with the table all the way to the side, there just wasn't enough room for a part this big. There was some room for something, but nothing nearly this big. So I went back to vertical, and I've been sitting here piddling around with shims and clamps, and I've got it in a good position. What I use to get it vertical is I put this pin in, which has a little bit of play, but not much. It's pretty good. So if I can get this pin to match this pin, we'll be fine. So the goal here is to get the part perfectly vertical so that you could bore the hole the way it's supposed to be. Here I'm showing checking the x-axis, or left and right as it's pictured. I also checked front to back. Took a while to get that placed that well. So I've got this position now. I'm tracing the outside, and I know that's just casting, but that's the best I've got to get the center of where that should be. And I've got it equal on pretty much every dimension, as close as it'll get. So that is the center of the hole that we're going to make. If we take it down into the hole, see it's hitting there. That's your first cut. I was getting some chatter, so I added an extra support, which seems to have helped. Alright, now I get to do that again. Yeah, safe to say this is a more involved repair than I thought I was getting into, but yeah, it is what it is. If I was to take this to a welding or a machine shop and have them bid on it and then wait for them to do it, it would cost a lot of money and it would take a lot of time. I'd rather just do it myself. Ideally, you would bore both sides with the same setup. That way you don't have any concern of the two not being perfectly in line with each other. But I don't have the ability to do that with my equipment. So I have to do one side, flip it over, get it vertical again, do the other side, and do the best that I can to get the two in line. So to start with, I just use a level. So I've got this vertical, and then when I turn it 90 degrees, it's also vertical. That gets me close. Now I'm ready to start clamping it down and get out the dial indicator. And then I'm going to need to shim and adjust slightly to get this so that it's dead vertical. Alright, we have it all clamped down. And this clamp here is just to keep it from chattering. I don't have that one very tight because it doesn't have a lot of support under it. It's actually putting its stress through the part, but that's fine. It's a big heavy part. We're going to make that egg a circle.
that is now a circle.
Well, now it fits like a hot dog down an even bigger hallway. Yeah, that's what I want. It's got 5 thousandths of clearance for grease.
I'm going to do two things with this. I'm going to weld it, but I'm also going to do an interference fit. So the measurement in here is 2 thousandths less than the measurement of this. In other words, this is 2 thousandths of an inch bigger than that. So it's not going to go in. But if you cool this piece down and heat this piece up, it should drop right in. So I'm going to throw this in the freezer. It'd be nice if I had liquid nitrogen. I don't. That's the best way to do it. But I have a freezer. I'm going to throw this in the freezer, and then we'll heat that up, and we'll drop it in. The bushing is still in the freezer. I'm going to get this up to temperature first, and then I'll go grab it and drop it in. Doing some math, I need a 180 degree temperature differential to make them exactly the same size. If I have over 300 degrees, I should have a thousandth and a half of clearance, and it should go in without too much trouble. Now, just in case, I'm going to have a little hammer here to have available in case it doesn't go so easily. Sometimes they don't, you'll get a little cockeyed and you need to coax it. And what I have here is just a little piece of threaded rod, 2 metal plates, so that it's got a plate underneath it. So I can drop it in and it won't come past this face. Obviously, it would drop all the way through otherwise. So we're ready to start heating. Let's go get it. Bam! Love it. It is so gratifying when it goes right in without any trouble. It's such a cool thing too, because there's no way now to get those parts different temperatures. So they just slid right together, but once it equalizes, it's not coming apart. The The second bushing is larger, so I have to make it out of this 3-inch piece. The first bushing, I was really lucky to find a heavy wall pipe that was perfect for it, but this one's solid stock.
Alright, I'm getting close to my final dimension, so I have to let that cool down so that I get the right measurement.
2.542 is the measurement right now.
It's 135 degrees right there. It has trouble reading it on the shiny metal. It's definitely hotter there than it is there, so it's probably 160 or something. Cooled off, and I am getting 41, 2.541. So I shrunk 1,000th.
So now that I have the outside diameter where I want it, I can flip it around, part it off, and start working on the inside diameter.
Off to the freezer I go. Woo! All right, how did we do? We are hitting there, and we're a little bit light on this side. In other words, that hole is slightly that way. I was pretty much expecting this. First of all, it's probably going to warp when I weld it. The pin wouldn't fit even if the holes were perfectly aligned. But with my setup, I just don't have any way to bore both holes in the same line, in the same setup. Because I had to flip this thing over, and here I'm using the casting to determine where the center of the hole is. If this casting is not in line with this, and castings are never precise, then your pin's not going to be perfect. In other words, I'm going to have to put this back on the mill once I finish welding it and skim a little bit off that side to get that pin to fit. It's not ideal. Basically, I'm putting some wear in the bushing before I even start. It is what it is. Way better than it was. Now, a line borer would be able to do this and keep them perfectly in line. I'll put a link to a video right here. This is a machinist channel that I watch if you want to see what I'm talking about. A line borer puts a rod all the way through, and then it spins around and you can bore out both holes on the same axis, and it gets it perfect every time. I don't have a line borer. I don't do this kind of stuff very often. It doesn't really make sense for me to buy one. For the record, I could have done one of these precisely and then done the other one and not drilled it out as far, planning on putting it back on the mill. Honestly, I was hoping that I would get lucky, which I guess is kind of a lazy way to do it. You have to have the hole all the way through because I need a reference on the other side, like how much do I need to skim. But I could have left like a 1/4 inch on one of these. And that's probably what I should have done. Then I would be able to get it pretty darn close to perfect. It's fine. It's going to be so much better than it was. See those little pits there? Yeah, I left those there intentionally to hold grease. Alright, that's BS, but it doesn't matter. It's not going to hurt a thing. So I'm actually better off than I thought, because after welding, the pin has a slight taper to it, and it won't go all the way in. So taking a little bit extra, sorry about the noise, taking a little bit extra out of this side, not a bad thing. So that's what I'm going to do. It will go through this one, and then I can use that to know where to skim it. The other thing I'm going to do is I am going to drill and tap and put some grease zerks in this, because I really think that's the reason that these joints failed. The rest of the joints were all fine and they all had good grease in them. These apparently were not getting enough. Alright, I'm set up on the mill again. I need to go 45 degrees that direction.
That's a little better.
This area looks like a gap on camera, but it's not. There's about 10 thousandths in clearance on this side. And so I don't have this problem again, I'm going to drill and tap for some grease zerks on this. Alright, now I'm going to get this thumb fixed up. You can see right there where the weld split. I've got the same issue down here. So I'm going to grind that so that I can make a piece that will bridge that, and then I can weld that from both sides and get a new light bulb. And I just realized it would probably be easier for me to do this repair first, because that's going to be a little bit in my way. I need to grind that flat and then make another bushing and weld it on like this one down here is. And I'll put the pin through when I weld so that I get it in the right place. That'll work. It's ugly, but it'll hold. That might be the ugliest weld I've ever done. And the pin still moves. And use this other pin in the other side to try to help. There, see, that side's in. So that should make it a lot easier to get this side in. There we go. There we go. So I just noticed it looks like there was a grease zerk that's broken off on the center, but there's a ton of play there. And maybe there was a grease zerk here, but there's no way to grease this thing other than taking the pin out and greasing it like I just did. Wish I had thought about these grease zerks when I had this off. I could have easily drilled and tapped it right then. It already has a hole in it. As long as that's not a hardened piece of steel, I should be able to tap that. Yeah. That was rather painless. Now I just need to figure out how to drill a hole in that. I'm going to see if I can set up my mag drills somehow. Now here's a little trick you may have seen me do on the mill, but I don't know if I explained it. You put the tap in the chuck. You don't tighten the chuck super tight, but taps are hard and chucks are hard, so they're going to slip. It's not going to grab that well. But that allows you to get your tap started straight. Basically, you just ease it in and then let the drill stop when it starts to slip. All right. It was disappointing because I was ready to get this thing back together to have to stop and do something else, but I hate leaving work behind to come back to later. It's nice to have this thing right, and then I can be done with it. I'm gonna make a washer to go there. Looks like I need like a 1/4 inch. This is the pin that had that snap ring on the other side, and then this mangled snap ring. And I think the snap ring would be okay if there was a washer there to keep it from pressing directly on the snap ring itself. Need to make 2 more washers. All right. Now we have a grease zerk right there. On that joint that failed, okay, it's all back together. All the grease zerks work. I fixed that one too. That one had been broken off, so I put a new one there. Put new zerks here. And that's the collar that I made, bushing, whatever. And I just drilled with the mag drill that. And got the washers on there. And everything's looking good. Let's put the bucket back on. See how it's now hooked on that and on that. Now it's a little tricky because the front of this is broken off. I think you're supposed to be able to just kind of hook that and pick it up, but apparently someone rammed it into something and broke it. So last and probably least, I do want to fix this side cutter that's loose. It's got one bolt that looks decent. The threads are messed up though.
this bolt's bent and this bolt is missing. I'll tell you what, man, this thing is amazing. I'm going to put some red Loctite on these. Obviously these bolts are too long. I'm going to cut them off and probably peen the ends. You know, rather than fooling around with it, I'm just going to weld them. I mean, these things get so torn up. If I ever need to take them off, I'm just going to have to cut them off. That's fine. All right, this little project is done. And now the bucket doesn't flop around like crazy. It's got a little bit of play in it, but yeah, that's way better than it was. Man, I'll tell you, I thought that was going to be a quick one-day kind of repair when I was tearing into it. If I had known it was going to be that involved, I would have done the tracks first. I'm always worried I'm going to throw that track, so I really need to fix that soon. But I've got some other things on my list that have to come first, so it's a good feeling though now that it's done. Everything's nice and tight. Took a lot of the slop out of this and everything's greased and I can maintain it now. So awesome. I hate this rock. You see it there? Yeah, me either. There it is. There's the bastard. Look how many times I've hit that with the bush hog. Can never see that thing, but it's sticking up just enough that I smash into it every time. So several years back, I tried to dig this out with my tractor. It quickly became apparent that I was going to be digging for hours. A backhoe on a tractor is useful, but it's not an excavator. Every time you need to change positions of the machine, you have to get off the backhoe, get on the tractor, drive it, and then go back. It has limited reach, so you're doing that all the time. It works you to death if you're doing a big job, and this actually is a bigger job than you might think. So I decided not to then, but now I have an excavator. So let's see if we can't win this fight. So I can see why this rock beat my tractor. This thing's huge. It goes down into the ground there, and it is spreading out that way as it gets deeper. Basically, it's too big. Like, even if I dig and dig and dig and uncover this thing, I'm not going to be able to move it. I'm going to have to go to plan B. And yes, a rock breaker is on my list for things to get for this machine, but for right now, I just need to get the top of that rock off, and I'm going to use what I have. That was just a strength test of the bucket. I can't believe how tough that rock is. There's no seams. It's not like sandstone where you could kind of get it to split. This is nothing but sheer stubbornness at this point. Let's see what I can do just with a hammer and a cold chisel. Sheer stubbornness. Man, I'm an idiot. Any companies out there want me to demonstrate their rock hammer for an excavator? I'm your guy. I'll be a little more off of that and I think we're good. Oh man, it broke off the end of my chisel. I hate this rock. See what I got there? Now hopefully that'll be just under the surface and I'll never actually see this rock again. My bucket repair holds water. Those holes up there, of course, are intended to be there. The holes that I filled were down here where the water is. And if you guys see me wearing my socks up like this, that's not a style statement. See that red tag? Those are my tick socks. In this tall grass, I'm pulling them up to keep from getting chiggers. If you don't know what I'm talking about tick socks, watch this video right there. This is one of the best tips I can share. All right, admittedly that was not a total win for the excavator. That was a heck of a rock, and I can still see it. It's right there, but it's much too low for the bush hog to hit it ever again. So I'm good with that. This is just a field. I just need to mow it, and I can do that now. So I'm calling this done. I got other stuff to work on. Here's another annoying mowing obstruction. This is a fight we'll be winning. Hey, you excavator operators, I got a question for you. I would much prefer to operate the track solely with my feet, but there's no good way to pull back on these with my feet. I mean, I have to hook my toes here and then my feet are in space and bouncing around. How is that supposed to work there? Let me see if I can show you what I'm talking about. So I can actually
drive forward reasonably well with one foot like that. It's not great, but it allows me to put my heel on the floor and keep things stable. But pulling back, I mean, all I can do is that, and I just have no control. When the machine starts jumping, my feet start doing this. Like, what are you supposed to do? It seems like there should be something back here for me to use with the floor to pull back, but there's nothing there, and there's no holes to bolt anything to. Not that I can't drill something, but how is that supposed to work? I should add, several people commented on my bucket repair, and they made a fair point that I didn't need to grind this, just leave the welds. The dirt's gonna grind it over time. Honestly, I didn't even think about it. I ground it because every time I weld, I always grind, not every time, but almost always grind afterwards and then paint it. And it was just out of habit. It didn't even occur to me. But yeah, I mean, these weld beads are sticking out. They're not a problem. Why not just leave them sticking out on the back too? Probably should have. Live and learn. Thanks for the comments. Thanks for watching. We'll see you guys on the next one.